Let's talk about a math problem that I guarantee has started more than a few arguments. It looks so simple, but people always seem to come up with two different answers. How can one little math problem cause so much confusion? Well, let's get into it. So here it is, 5 plus 3 times 2. Now, if you just go left to right, you probably did 5 plus 3, which is 8. Then you multiplied by 2 and got 16, right? But what if you did the multiplication first? Then you'd have 3 times 2, which is 6, and 5 plus 6 is 11. So we have two totally different answers from the exact same problem. So who's right? Is it 16? Is it 11? Can they both be correct? Well, the short answer is absolutely not. You see, in math, we just can't have that kind of ambiguity. There has to be one single correct answer for everyone. And that's why this is so important. Think about it. Math is a universal language. Whether you're an engineer building a bridge or a programmer writing code, everyone on the planet needs to get the exact same answer from the same equation. And for that to happen, we need a universal set of rules. So here's our game plan. We're going to break down the official rules of order. Then I'll show you how special symbols can let you take charge. After that, we'll tackle a more complicated problem together. And finally, we'll talk about why all of this matters way beyond a math class. All right, let's dive right in. The solution to our little two-answer dilemma is something called the order of operations. You can think of it as a set of traffic laws for math that everyone has agreed to follow just to make sure every expression has one and only one final destination. And the basic rules are actually pretty simple. It's like a 3-level hierarchy. First, you take care of any powers. On the next level, you handle all the multiplications and divisions. And on the last level, you do all the additions and subtractions. That's the basic pyramid. Okay, now that we know the rules, let's head back to our original problem, 5 plus 3 times 2. So looking at our hierarchy, what gets to go first, addition or multiplication? Well, according to the rules, multiplication is on a higher level than addition, so it gets priority. That means the very first thing we do is multiply 3 by 2. That gives us 6. So the problem is now just 5 plus 6. And now there's only one thing left to do. We add 5 plus 6 is 11. And there it is, the single universally correct answer. Mystery solved. But wait a minute, what if you wanted the addition to happen first? What if the logic of your problem demanded it? Well, math has a tool for that. And that brings us to our next topic, the powerful little things called grouping symbols, which let you take control of the order. We're talking about things like parentheses and brackets. You can think of them as giving a VIP pass to whatever's inside. They basically shout, hey, do the math in here first. I don't care what the other rules say. They're your tool to override the standard order. And man, do they have power? Just look at this. On the left, with no parentheses, we follow the standard rules. Multiply first, then add. We get 31. But on the right, those little parentheses force us to add 6 and 7 first. That gives us 13. And 4 times 13 is 52. A totally different answer, all because of two little symbols. So what happens when you have parentheses inside of other brackets? It's like one of those Russian nesting dolls. The rule is simple. You start at the very center, the innermost symbol, and you solve your way out. Okay, it's time to put it all together. We've got the standard rules, and we've got the grouping symbols that can break those rules. Let's combine all of this and solve something that looks a little more intimidating. So here it is, the complete 4-step process. First, always deal with what's inside grouping symbols, working from the inside out. Second, handle any powers. Third, do all the multiplication and division as you see them from left to right. And last, do all the addition and subtraction, again, just going left to right. All right, here's our challenge. Yeah, it looks like a bit of a mess. But trust me, if we just follow the procedure, we can untangle this no problem. Let's do it one step at a time. Okay, step 1, grouping symbols. We see parentheses around that 1, but there's no operation inside them. So we move to step 2, powers. We've got 1 squared, which is, just 1. Easy enough. Our expression just got a little bit simpler. Now for step 3, multiplication and division, moving from left to right. So first we see 28 divided by 4, that's 7. Then we've got 2 times 1, which is 2. And finally, 5 times 3 is 15. Look at that. Our scary expression is now just 7 minus 2 plus 15. Much better. And now for the final step, addition and subtraction, left to right. So 7 minus 2 gives us 5, and then 5 plus 15 gives us our final answer, 20. See? When you follow the rules, it all falls into place. This table is a perfect example of that inside-out rule. We start at the very center, 3 minus 1, which is 2. Okay, now we're still inside the brackets, so we handle the power next. 2 to the power of 3 is 8. Now we can finish what's in the brackets. 6 plus 8 is 14. Almost there. Next, we multiply 2 by that 14, which gives us 28. And the very last step, 5 plus 28 is 33. Done. So for our last section, let's zoom out. We figured out the how, but now let's talk about the why. Why does having this strict set of rules matter so much anyway? It's really about more than just passing a test. This quote really hits the nail on the head. The whole point is to give a single meaning to every expression. It's an agreement we've all made, all for the sake of clarity and to make sure we're all on the same page. And you know, this idea is everywhere, not just in math. Think about it. The rules of grammar in a language allow us to understand each other's sentences. The syntax of a computer programming language tells a computer exactly what to do, with no confusion. All of these are just rules of order designed to create a clear, shared language. Which brings us to a final thought to chew on. Math has its order of operations for perfect clarity. So what are the unspoken rules of order that we all use in our everyday conversations to make sure that we actually understand what the other person means? Something to think about. Thanks for watching.